Alright, we can calculate the mean and median, but really when we get to science, what we're interested in is differences. So this is an example of a comparative study where we tried to germinate seeds in cold versus in warm. And by cold, we just mean, we exposed it to the air-conditioned room versus, say, the outside room. And so here's two sets of data. Now, if we just look at the means, we say, oh yeah, okay. So it took the warm group less time. But if you notice on individual samples, some are faster, some are slower. So the question here we want to know is, overall, is that an actual difference between the two groups? Or if we did this hundreds and hundreds and hundreds of times, would we actually get means that are pretty similar? So in order to do this, we're going to have to figure out the variance and then the 95% confidence limit. So this is over on page 23 of the packet that we're working through. But I wanted to show you, again, how to work smart, not hard here. So we've already calculated our means. So now we need to figure out our differences. And we're going to do the squared differences because we need that in order to calculate our variance, which gives you an idea of how big of differences we have from the mean. Because realistically, if everything was all 2s and 3s, that would be a really small variance, so we could be pretty positive about our mean. Whereas if it was anywhere from 0 days to 100 days, that's a massive variation, which means that this mean could be anywhere to the left or right. So we're going to start calculating our differences squared. So I'm going to type a label here. You don't have to, but it helps me keep track of stuff. And again, we're going to auto-calculate this. So for this, there's not an insert equation. We're going to actually create our own. So you're going to start by typing the equal sign, which tells you, or tells the program, hey, I'm doing a calculation here. So what we're going to be calculating is the difference between an individual sample and the mean squared. So we're going to use two different things here. The first, this is a relative identifier. So it's saying, hey, whatever is to the left, I want you to take that number. And now we're going to give it an absolute identifier, which means subtract the same thing every time. So down here, we're taking B3. So we're going to say $B, $30. And that says, no matter where I copy and paste this, I want you to always use this number. That's what those dollar signs do, is fix it. And then we're going to square that difference. Now this is part of why I love Google Sheets. It auto-fills for you. And what I want you to notice is no matter where I click in here, that first number changes to always be whatever cell is to the left. But then that second number is fixed. It is always subtracting the mean. Now if you don't put the dollar signs, it's going to, say on the second row, subtract the second one down, and so on and so forth. So that's why these dollar signs are important. So we can do the same thing over here, equals whatever is to the left minus this number down here, and we're going to staple that in place with our dollar signs and autofill. All right, so we've got all of our differences squared. So now we need to figure out, all right, what's our sum of squares? And again, if you're following along that table in page 23, you can see the sum of squares there is what we're going to use to get our variance. Okay, so our sum of squares, which is SS. And again, we're going to use these smart equations here. Highlight. Boom, there's our sum of squares. And then we can figure out our variance. And I'm going to write a label here. Our variance is going to be equal to that number divided by however many samples we have minus 1. So we have 26 samples, so we're going to divide by 25. And that's our variance. So we're going to copy this over here, do the same thing, equals sum. Yeah, look at that, it already fills it for you. And then we're going to do our variance. Now the variance is giving you a rough idea of how much each individual measurement is off from that mean. So we have some that are super far off and some that are not very far off. And remember, this is the square. So when you're seeing that, for example, our variance over on that last data set is a 3.3, an individual measurement is varying by the square root of that. So go ahead, go calculate the variance in your honeybee data, and then you'll move on to the next video.